Welcome to the More and Beyond session at the EU R&I Days 2022. The shortage of chips and our dependency on imports hurts everyone, every sector, every part of our society. So it's time to act and to improve our capacity to act in order to achieve a reasonable level of autonomy in Europe. So the EU has proven that it can act fast. Think of COVID, the vaccines. Think of the 750 billion Recovery and Resilience Fund we created. The EU has also proven that we can bring back production to Europe in the case of batteries, where we have with industrial alliances and investments shown that this is possible. And the same is behind our commitment with the CHIPS Act to bring production of chips and the next generation of chips to Europe. So what is behind the title More and Beyond? Moore's observation is that the number of transistors on an integrated dense circuit doubles every 2 years. This is not automatic and it requires investments. So the question is, should we invest in these, in more efficiency? Or do we need also to invest in other elements? So the question to invest in different functionalities for chips, for instance, combining processors and memory in one step. Moreover, as we reach the physical limits of silicon, do we need to invest in new materials and new expert skills and new manufacturing technologies and capacities which go along with it? And thirdly, certainly not least, sustainability and circularity of chips. That require new production and performance characteristics of chips. So to explore the way forward for us here in Europe, we have 4 eminent doers and thinkers with us from industry, from academia, and from research and technology organizations. So I'm very happy to welcome Ralf Bonifeld. He's Senior Vice President at Bosch and Chair of the Key Digital Technologies Joint Undertaking of the EU, a 1.8 billion public-private partnership, which will soon be the CHIPS undertaking with additional budget. I'm very pleased to welcome Adam Klimčić. He is the R&D manager at on the Czech side of onsemi. onsemi, a global semiconductor supplier, relying on more than 30,000 people. And Adam has a particular expertise in silicon carbide. And then I'm very happy to welcome Samira Nick. She's a program manager for quantum technologies and electronics at the European Innovation Council. And these program managers at the Innovation Council are very innovative and very influential people. They manage a portfolio of projects to ensure impact and scale up. And I'm very happy to welcome as our fourth speaker, Laurence Piketti. She is the Deputy CEO of the Commissariat, the Atomic Energy Commission in France, a French public research organization relying on more than 20,000 researchers in all fields of technology and research. So you can engage with our experts here via Slido. Just use the toolbox on your screen to make it happen. So let's start with you, Ralf. This joint undertaking on key digital technologies. What is its role under the Future Chips Act?
Yeah, Peter, let me take some time to explain what Kdt is about, and then I come to your question. So we are a 3-party partnership between the European Commission, 31 participating states, and 3 industrial organizations, associations. And what we do is we work on the electronic component and system sector in the European Union. We want to strengthen that sector by providing funding to relevant focus topics. So as every electronic system is using chips, it's pretty much a natural given that the European Chips Act has an impact on KDT. And that's the reason why we are in a transition towards the CHIPS joint undertaking. What does that mean? We have 3 pillars in the CHIPS Act. 2 of those are impacting KDT. This is a pillar number 1. This is the Chips for Europe topic. It's materials, technologies, pilot lines. And it's pillar 2, which is the capacity topic. We want to build up capacity through first of a kind lines. So these are the 2. And the question is now, the key question, where should we focus on? And therefore, I liked pretty much the title of this session, More and Beyond, because it's both. If we look at the global semiconductor industry, this has built up over the course of the last 20 plus years, a work split of different regions. So certain regions are good in MPUs, like Japan or the US. Other regions are good in memory, Korea, for instance. And Europe is pretty much at the forefront of sensors. So there's no region in the world that can cover the broad spectrum of all kinds of semiconductors. And therefore, every region is dependent on every other region. So what we need to do now going forward is, because I don't think this will change immediately, it will take a long time until every region could become fully independent. Therefore, we need to do 2 things. The first is we need to strengthen where we are strong at in Europe. And this is definitely more at the beyond part. And on the other side, we need to also ensure that we catch up in the more, because this will become more important in 2030 and beyond. So we will have certain applications in the communication and the computing, including the AI part space, that will depend on these kind of technologies. And if we do not start to catch up now, we will not make it up to that. But strengthening the strengths is so important, because then we have something to offer to other regions where we need something from, and they can get from us what they need where we are so strong at. So this is the whole thing, and this will also be the impact on the KDT towards CHIPS JU transition.
Thank you very much, Ralph. Catching up with Moore, that is a nice challenge, and I hear you say loud and clear, it's both. It's Moore and beyond. So thanks a lot for this introduction. Samira, let's come to you. What is the role of the EIC now that we've listened to Ralph and what we will do under the CHIPS joint undertaking? What is the role of the European Innovation Council, and related to that, the role of startups in bringing research to on chips to the market?
Thanks, Peter. So, as you know, the European Innovation Council is really focusing on creating unicorns. We call it the Unicorn Factory of Europe, because there are a lot of amazing research that are happening in Europe, but they are not really transferred to the market. So one of the main points that we are trying to work on is to strengthening the relation between the startups and the real market and big industries, and creating unicorns and bringing the innovation to the market. So CHIPS Act is a big initiative, and in relation to that, EIC has the mandate to spend 300 million euros for the CHIPS Act to help the CHIPS Act to move forward. And this is a very important initiative, because we are dealing with many important startups that are creating very innovative ideas, and they don't know how to bring this idea to the market, or they lack the financial support, or they lack the business expertise. This is what EIC is doing, trying to help them to bring them to the market. So specifically for the semiconductors, the startups can play an important role, because usually the big manufacturing industries or the large companies, they have a specific roadmap and they are sticking to that. But the startups are really having any kind of interesting idea or research that is reaching to a specific level, and by a little help, they can really be a game-changing innovation in the market. For instance, I recently worked with a project that they are actually a very at a Pathfinder level. They're basic research from the scratch, but they came up with a really interesting idea for the semiconductor industry, and they already are in contact with one of the biggest equipment manufacturing companies in Europe for semiconductor industry, and they are working to creating new types of chemicals, new types of, I don't want to reveal so much, but you know, it's impressive how a small group of researchers, when they put together their efforts, can make a big change.
So Samira, couldn't you predict that we would have some unicorns in the semiconductor business?
I'm quite sure we will have, yes. We have many interesting projects and startups that in the field, and now we are trying to put more focus on our accelerator program for the CHIPS Act to have more, as you said, like unicorn-oriented goal support, and I'm sure Europe will be very successful. If I can add one more point, is that it's very important to support these startups in Europe, not so that we don't lose them, and we will keep them as European unicorns.
I couldn't agree more with you, Samira, on that. Let's turn to Adam. Adam, Samira spoke about the necessity or the importance to link startups with the big companies. You work for a US-based big company. How do you see the role of these companies in Europe and for investments in Europe?
Yeah, Peter, thank you for a nice introduction. So, yeah, well, foreign investments are important indeed, as they bring benefits not only for investing company, but also for the region where the investment is targeted, as it catalyzes growth there. Semiconductor investors, like those in other industries or areas, are looking for places with relevant resources. For semiconductor companies, the most important resource are skilled people. This was also main reason why onsemi, formerly Motorola, decided to invest in Rožnov pod Radoštěm in Czech Republic, as there has been semiconductor production facility with several decades of experience. Also important is whether the region can provide pool of technical talents for further growth, mainly students of technical schools at all levels and universities. Investors also look at further aspects like availability of facilities necessary for semiconductor production, like water or power grid, and possibility of local supplies, and etc. Very important role for the decision is also attitude of regional or country governments. Large investments are putting financial pressure on company, and any incentive is very helpful. The government needs to understand that any high value added industry brings significant growth for the region, and subsidy budget will thus pay off in a better standard of living in the region. Local government must also act wisely while setting up and maintain a long-term education strategy, which should create already mentioned pool of talents and experts. To provide you with a real example, here are the data for current onsemi investment in Czech Republic. Onsemi is expanding its silicon carbide wafer plant in Czech Republic with an investment of nearly €500 million over the next 2 years. The expansion of the plant in Rožnov will boost the capacity of polished silicon carbide and epitaxial wafers by a factor of 16 over the next 2 years, and create 200 jobs by the end of 2024. So far, onsemi has invested more than €150 million on the expansion of the Rožnov site, and plans to spend an additional 300 million through the 2023. This is to meet demand for silicon carbide power devices for electric vehicles and renewable energy applications, which are key to the supply of chain of the European car makers. Thank you.
Thank you so much, Adam. We'll come back to silicon carbide in a moment. What I take is it's an ecosystem. It's skills, where Europe is probably very strong, but it's also local support, the role of the regions in creating this ecosystem. And that brings me to Laurence. Laurence, the CAR. big player, important player, together with some other big players in Europe on chips. How do you see your role in the CHIPS Act and the production of semiconductors, of more and beyond more, or more itself?
So, thank you very much for your question. So the CHIPS Act is based on 3 pillars. The first one is about European technology leadership. The pandemic and now the war in Ukraine have revealed the vulnerability of Europe to supply chain disruption. And semiconductor is one of these key sectors that are vital for so many economic sectors. Yep. So technology leadership is therefore a condition for Europe to reduce its dependencies and regain strategic autonomy. In that regard, Europe has a strong asset with 3 world-class research and technology organizations, RTO, CEA in France, IMEC in Belgium, and Fraunhofer in Germany. Our 3 organizations have a long history of working with the industry. CEA, for example, is an historical partner of ST Microelectronics and is the cradle from which Soitec has become a leader in silicon wafer production. And so we, RTOs, invest considerable amounts in state-of-the-art experimental platforms, the clean rooms and their highly complex equipment, which are essential to ensure the adequate R&D and then transfer to the technologies developed in our labs to industrial partners before they enter in the deployment and production phase at large scale. And that is precisely how we intend to contribute to the CHIPS Act. The EU CHIPS Act identifies a few strategic semiconductor technologies for which Europe should seek technological leadership and for which the Commission proposes to set up pilot lines with co-funding from the EU member states and stakeholders. It's the race for advanced nodes, FD, SOI, and integration and advanced packaging. And these key technologies are precisely those where CEA, IMEC, and Fraunhofer are international leaders. And for example, CEA is the inventor of the FD SOI technology I just mentioned, and this technology offers very strong perspectives to reduce energy consumption and carbon footprint, which will become a major issue in the coming years for the entire digital sector. It is particularly well suited for strong European more than more markets. And so at this point, let me stress 2 important issues. So CEA, IMEC, and Fraunhofer are working together on a common strategic program for the implementation of the technology pillar of CHIPS Act. And this work is done with the constant objective of creating and supporting a global European ecosystem open to access for stakeholders, academic and private, from across the European Union.
Laurence, that's very interesting. And Samira gave us some encouragement saying that there might be European unicorns. Do you see in your cooperation the possibility that we actually accelerate from the development from lab to fab, which is one of the challenges of the CHIPS Act and an important critical element to increase our capacities and improve our strategic autonomy?
Yes, I think so. I think that the collaboration between 3 very important actors in Europe on microelectronics as CEA, IMEC, and Fraunhofer will allow us to increase and to go faster and to reach our independency and to have a, very strong very strong collaboration in Europe.
Yeah, thank you. Thank you very much. Adam, let me come back to you. You mentioned silicon carbide already. Do you see that we have reached the limits of silicon, and which kind of materials do you see we should prioritize?
Yeah, that's a very interesting question. Thank you for that. Yeah, the silicon is under strong pressure, but even though the silicon is really on its limits in some applications, it will stay dominant for a long time still. Silicon is very mature semiconductor material with very long history of development and a lot of manufacturing capacities built worldwide. This makes it very reliable and cheap. Still, growing expertise and knowledge also allowed for some very smart innovations which pushed silicon literally over its limits. However, there are some applications where silicon loses ground, like, for example, high power chips. For simple explanation, high power applications are those where voltages are higher than this coming from ordinary home wall sockets, so 240 volts. These days, mainly traction system in EVs, trains, electricity conversion in renewable power stations, for example. In these high power applications, mentioned silicon carbide, which is semiconductor material with wider bandgap, provides significantly better efficiency at high voltages, and it can save up to 10% of energy during each conversion. It is still rather young material, which is in focus of number of research activities, but growing knowledge, experience, and manufacturing capacity for silicon carbide chips will make it dominant material in the high power application in coming years undoubtedly. And onsemi is well aware of this development and is part of the effort with an aim to be market leader and prepares massive investments in coming years. Thank you.
Very interesting. It's also then about applications. Before we continue here, there are already some interesting questions on Slido. Thank you to all of those who have already engaged here with our speakers. So the first one I would like to bring to the panel is why the European industry has been so late in the field of semiconductors. Or you don't agree with the assumption at all? Who would like to come in? Ralph?
Let me take it. So I don't think that we are late. I explained earlier that this split that we had across this global semiconductor industry used to work very well in the past. And the reason is not just that the competencies are in certain regions. The reason is also that the regions focused on that to grow this specific subsector of the semiconductors to a certain number that economies of scale play in, and that at the end of the day, it is commercially more attractive to everybody globally. And therefore, we have just sorted out where are the competencies in the world best. And in Europe, sensors, power semiconductors, RF, these are a few examples where we put the money on in the past and where we really grew up to a leading region in the world. So question came now up through this crisis where certain parts that are not done in Europe, that are designed in Europe, but not manufactured in Europe, this is maybe better to say, that these were simply not available because of these circumstances from COVID and certain sectors that grew up faster than anticipated. And I don't think that we have missed it in the past. It was just the setup of the past that led to the situation we are in today.
Thank you. Any addition from our other panelists? If not, thanks for your patience. Let me turn to Laurence. We spoke about materials and that silicon will stay, but we need new materials for future applications, new applications. So you have signed the Materials 2030 Manifesto, which is a visionary statement of making materials contribute to the regenerative nature of production, so delivering on our circularity objectives notably. So which opportunities do you see from the CHIPS Act from a materials perspective?
Yes, as you said, I think the Materials 2030 Manifesto at the beginning of this year. And I think it's a starting point for us. The starting point was the observation of a relative decline in the priority given to materials R&D in research policies and programs, whereas it represents a key driver for innovation in all sectors, and in particular to find more sustainable products and processes. And precisely, one of the main issues for the digital sector will be to significantly reduce the energy consumption of electronic devices. Without change, the electronic sector could amount to close to 20% of CO2 emissions in 2030. And there is therefore a major challenge to find new materials with higher energy efficiency. For example, the FD-SOI technology mentioned earlier is a good response to this concern, with a 30 to 40% gain in terms of power consumption. And so the new chips designs, new computing architecture and paradigms will need to be adapted to different application markets. In that regard, advanced materials will have a strong role to play. And this is true also for more than more markets, of course. And so we need the EU Commission, member states, industry and research to leverage collaboratively the interplay between advanced materials, digital technologies and circular strategies. And this objective is at the core of the Materials Manifesto. Mm-hmm. And so I would like to add that TA also expects that within the CHIPS Act or in other programs, some rooms remain available for R&D and technology development, not entirely driven by short-term needs of the industry. There should be room, in particular in Horizon Europe or the new CHIPS joint undertaking, to support more upstream R&D to prepare for longer-term generation of technologies. And so the Material Manifesto governance should aid in setting up a roadmap for this type of R&D.
That's a plea which I entirely endorse. Thanks for that, Laurence. But let's turn to Ralph now. I mean, there are two aspects. The energy efficiency of chips while in use, but there's also the question of what happens after use, circularity, and what happens during the production. This is probably an area which is not so far in the full focus. Or would you say it is something which is already fully addressed?
It is changing now. This I can say. We have a lot of OEM customers that currently ask to really reduce the carbon footprint of semiconductors. And it starts from the production up to the use of those. And so let me elaborate a little bit on that. So first of all, the semiconductor industry uses a lot of electricity. Yeah? And we first need to ensure that this electricity is coming from renewable sources. And we need also to ensure in Europe that these renewable sources are affordable, so that the semiconductor industry in Europe is not having a competitive disadvantage to other regions. And then if I look at the circularity, there are three things that are coming up to my mind. The first thing is recycle, the second is reuse, and the third is repair. Let me start with recycle. So obviously, it's not so easy to decontent a tiny chip into its individual hundreds of different materials that are in. But if you look at the production, there's a lot to do there, where we can recycle material, chemicals, for instance, metals and whatever, during the process and better use them as we do today. The second thing, reuse, is maybe sounding a little bit strange, but it is something that is worth to think about it. If you look at certain applications, maybe mainly in the consumer area, that have a use of a lifetime of maybe up to 4 or 5 years, we have semiconductors in that have a lifetime that is several times more than what the final product is used. And the question is, can we use these semiconductor products that are built in there for different use cases? And do we find clever ideas how to make this transfer happening? This is what I call reuse. And the last thing is repair. You know, we have created a mindset in the last 10 years that we buy goods from the market, and once they are not functioning anymore, we throw them away. And if you take, for instance, a smartphone where we have many, many different semiconductors in, the question is, do I need to throw it away just because of a malfunction of a single chip inside? Or could I repair it and then have a longer lifetime of this product? This is also a question we need to ask ourselves. Kdt currently, in one of the last calls, is putting a focus on the circularity as well. So we have a focus topic out on eco-design smart electronic systems. So we start to engage with this topic, but there is still a long way to go. But the end customers are asking for it. There is a demand, and therefore we need to do it.
That's very encouraging. Huh? The bigger the demand, the faster the investments. Can I follow up directly with you, Adam? When you work on new materials, silicon carbide, do you have from the very beginning, from the design phase, the recyclability, the reuse and repair in mind? Or is that coming only later?
Well, yeah, it needs to be involved in that, for sure. Each corporate, I believe, is following very strict environmental rules, and this kind of questions like renewability, recyclability is something which needs to be counted in all designs. So yeah, these products are made with environmental aspects in mind. I need to admit.
Mm-hmm. Samir, can I come to you with a question on skills and people? We know how important it is, and how can we ensure that Europe has enough people, knowledge and capacities to design and manufacture chips?
Yeah, this is actually, as you know, semiconductor industry is a difficult industry. It needs a lot of skills and a lot of expertise. So as we heard a few times, we have a lot of expertise in Europe, and what is important is to make sure that we are also having plans for future. But for the moment, if we think that, for instance, with the CHIPS Act initiative, if we are looking for expanding our capacities of the current, for instance, foundries, or building a new semiconductor foundry in Europe, we would definitely need more and more people. We have many experts, European experts, that are currently working in US or in Asia. So I would say having a homecoming program or having something very attractive for them to take them back in Europe to help us build this industry stronger will be a very important step. But at the same time, for future, I mean, this will be an industry that is thriving, and there will be more job opportunities, of course. So I think the member states and also the industries should have good partnership with academic institutions to have dedicated programs for educating hardware engineers, technological aspects that should be handled, and even facility management. These are very important skills for the semiconductor industry. Another point, I think, is having in mind that this is a difficult working environment. I used to work there, I know. This is why there are so many people that are dropping off the industry. There is a high turnover for people, especially, for instance, for the operators that are working long hours in the labs. It's a difficult job. You don't drink or you don't eat for a few hours. You have to be in a special suits. It's important to make the life and work balance a bit better for these organizations, and try to make it more attractive, I think, definitely. And also, I think the education and investment in having expertise shouldn't be just for really technical and high-level jobs. It's also important to think that the more knowledge your operators have, the less errors happens in your facilities, the less delays you have because of a big equipment is broken because of an error of lack of knowledge. So I think at every level, it's very important to invest in knowledge and education of people.
Mm-hmm. Thanks a lot, Samira. That fits very well with the question we have here from our participants. And that's the question, how can we improve the collaboration of academia and industry in this field? Would you have an immediate answer? Because it's also linked to boosting startups.
Yes. Well,
or do you see is sufficient cooperation already?
Well, at one level, we have, I mean, many, as you know, in all the projects that are financed by the European institutions, as these, we have so many collaboration with the academy and universities. We have many researchers that are working with us in different fields, especially in the digital field. I can tell you that like 50% of our Centura startups are in digital field in EIC. So there is a big connection already, but the important thing is to support these groups, because I think many of these amazing groups that they have very good ideas for a special innovation, they don't know how to build a business. Mm-hmm. And that's where we really need to support, I think, the graduates or the projects that are coming from the academy, to help them to create a business, to help them to protect their ideas. This is one of the most, I think, important things. The IP, the intellectual property ownership, is a very important thing that is usually neglected, and people are publishing because there are different let's say, victory levels in, like in academy, you want to publish more, but in industry, you have to first protect your idea. So I think there are so many ways that we can boost this. It's more and more by supporting financially to help them. I think it was very important point about the RTDs as well, because many of these academy graduates that are starting, they have a seed money, they go to a special level, and then they're blocked because they don't have the access to the facilities to go to the next level to create their proof of concept. So a lot of things can be done together with industry, universities, and the RTDs. Mm-hmm.
Thanks a lot, Samira. This is a question to all panelists, whether from industry, Ralph and Adam, or from the research and technology organizations. How is it for you? Is it difficult to find and attract and keep the right talents and skills?
So from my point of view...
Ralph, please, yeah.
So from my point of view, and we mentioned it already earlier, a key challenge for us is how to come from ideas to real products on the market faster. And in my opinion, we have a lot of talents in the RTOs, in the industry, but the way we work together today is making us slow. And this has to do with pilot lines we start to have in research organizations, in the academia, and then we develop to a certain the proof of concept, and then we build another pilot line in the industry, and then we scale up. And this takes by far too long. So we need to shorten this process and need to tear down fences and walls that are in between, and need to work more intensively already in the research phase. And we need to come through this proof of concept and then industrialization phase much faster.
Mm-hmm. Thanks. Laurence?
Yes, just to say that RTOs have a long experience of working both with academic and industry, and it's why we use a lot of platform to the transfer to industry, and so it's the core of our activities, in fact, in RTO organization.
Mm-hmm. Adam, would you like to add? I mean, you mentioned that there will be 200 new jobs created. Do you find the right people easily and you can keep them?
Yeah, I need to admit that finding talents and keeping them in the industry or in the location, as Rojno is not easy task. As Samira mentioned, this job is really not easy. You need to spend a lot of time in clean room, in this clean suit and so on. It's so, yeah, and that's something we are working on with different schools and universities. We are trying to solve it, but I need to admit that it's not easy task.
Samira spoke about protecting international intellectual property, and this is a possible barrier for cooperation with academia. I need to make a bit of publicity here. We will come up soon with a code of practice on how to manage intellectual assets, which is much broader than just protecting. Something which might help the cooperation industry academia, and a very important topic here. So there is an interesting question here in our chat. I'm not so sure how to handle it. The question is, how can we make chips a common good? And I imagine the background for this question is they are so transversal, they are so needed in every also life-saving equipment, that this is the reason behind. At the same time, for a startup, if you need capital, you need also to have your assets protected. So is this question resonating with someone here in the panel?
Well,
I see the clear no.
well, what is it? This is related to the price of the dice. If the price will be reasonable, then it will be common good, and this means that to lower the price of the chips, we need to increase the capacities for manufacturing. With that increased capacities, we will decrease the cost of the production, the cost of the development, and then it will be common good as silicon basically started to be with the years of investments.
Mm-hmm. Anything to add?
I would just say that, I mean, this is a very, very expensive industry. So this is, it's not an easy task to do. And of course, as mentioned before, even if we want to increase the manufacturing capacity to make it cheaper, there is a need for really huge investments to make that happen. Mm-hmm. I mean, building up a new facility takes few years, and all the equipments, all the talents, it's very expensive. So it's a difficult task, I would say.
Hmm. Good. I don't see anyone from the panel to go to the Ralph.
Maybe last point.
Last point.
I'm asking myself if it would be a common good if we would still have the level of innovation we have today. So if you have innovation, you want to have an advantage from that, and then it does not end up to be easily a common good.
We need.
Short point.
Okay, well taken, well noted. I think Adam's approach to say if it's cheap, that it's coming close to common good, we can make it accessible. So the challenge now for you is to end with one short closing statement in the remaining 2 minutes, what you take out from this session. And I start with Samira here.
I would say Europe should continue supporting the startups, especially at this important critical time, to have the Europe sovereignty in the chips crisis.
Adam.
Yeah, so my message would be that if we want to support and subsidize, we need to act quickly. Thank you.
Super clear. Laurence.
And so I think that in the research for more autonomy and sovereignty, CA, IMEC and Fraunhofer are a major asset, and the pilot lines of the CHIPS Act will reinforce our collective capacity to support the European industry.
Thank you, Laurence. Ralph.
So I see the European Chip Act to prepare us better for the even more digital age to come. If we balance this more and beyond well, I guess we are well prepared.
Thank you all. More and beyond for Europe's strategic autonomy. Thank you.